So welcome to the OCP Global Summit. My name is Megan Diefenbach. I'm a program manager with Facebook specializing in security programs supporting our data center facility space. So here with me today, we have a couple of key folks from across the industry that specialize in securing our industrial control systems that support our data centers at scale. So representing the hyperscaler perspective, we have Ehern, a data center engineer at Google. Then we've got IK, a data center security engineer at Facebook. And then representing the vendor point of view, we have Todd, a global solution architect at Schneider Electric, and Matt, a product cybersecurity leader at Johnson Controls. He and his team work to make our products more secure. Over the past year, these individuals have been working on the data center facility security project, focusing on developing frameworks that will build up the security posture in the ICS environment. In this panel today, we'll be discussing the specialized nature of this space, the unique requirements that set it apart from the more traditional IT cybersecurity world, and then focusing on the work that this group has been doing to help track and monitor this unique space. Now, industrial control systems have been around for a long time. So ensuring that our environments are protected for optimal availability and integrity of our data centers can't be new. So with that in mind, my question for the team is, why security? Why now?
Thanks, Megan. So that's a good question. Yeah, so it's actually been top of mind recently with prominent attacks like Colonial Pipeline and SolarWinds, making us question whether, entities like what we're responsible, like the public cloud, are also secure. You've probably read in the news a number of hyperscalers are also addressing this concern through either acquisitions or spinning up their own internal programs. Nobody wants to be left behind and vulnerable. Good security is really table stakes now. Attacks are becoming more bold and sophisticated in their ability to compromise infrastructure, and we want to get in front of this as an industry. So, especially as the public cloud continues to grow, we have a responsibility to our user and customers to keep services up and available. Our individual data center campuses are becoming ever larger and more interconnected. So an attack today has the ability to create an outage across a much larger region than was possible several years ago. And growth presents scaling challenges too. What was once one-off solutions to address security at a local level becomes snowflakes that each have their own unique security profile and create technical debt that's unsustainable.
That's a good point, Ehern. And to piggyback off of that, over the last decade, data centers have become critical infrastructure. So many companies have been empowered and exist because of the data center industry, and the capacity built out in these facilities are now the bedrock of the world economy. Part of the allure is really the scale that the data centers provide. Scale is something we all want to enable for our organizations and to provide products or services. So the question we need to answer is, how do we accomplish this securely, given the nature of these OT systems and that support the facilities that we have?
So why the focus on OT in particular, though? What's unique in the space?
Yeah, I'd say our customers depend on us to deliver secure solutions, and it's important we work together to achieve that. One of the main goals through this work stream is to collaborate on how we can improve the data made available from our devices that help prevent cyber issues and also detect them earlier. A few examples of this would be, can we standardize the types of information we provide on device boot up? I'm this type of device configured to use this protocol with this level of user permission. Or can we simplify the process of patching devices when vulnerabilities are found? Could we standardize around the types of logs and messages made available for systems extracting data from these devices? There are a few standards today I wanted to mention quickly as well. Through the course of our work so far, we've looked at IEC 62443 and NERC just to see how we might be able to complement what already exists today.
Okay, so thanks for that. But what about the environment itself? For our vendors on the panel, Matt, Todd, are there specific challenges to OT as opposed to traditional IT equipment?
Well, I think we could say we all want IT and OT to be secure, and at as close to the same level as we can manage. However, the use cases are substantially different, right? Consider a case where consider where you have to deal with patching, right? Imagine a 0 day in something like a browser or versus a vulnerability in something like an industrial control system? Well, rapid patch distribution is something that we all like to see across the board and is largely a solved problem in traditional IT systems today. We've got self-updating client OSs. And that's fairly straightforward, but the infrastructure isn't necessarily in place for building management, right? Patching a fire detection panel requires a much more careful and regulated process. It's got to be carefully verified and vetted. Sometimes it even requires testing in the actual site, on the actual location, when you're dealing with any sort of updates or changes. So the connectivity levels might be vastly different too. In some cases, not at all, right? Patching scenarios might even require what we would call a truck roll. We actually have to send a van out with a technician to go and do something like that fire panel upgrade. And that's not something we see in more traditional IT, right? And the browser maker doesn't typically send a van around to install a new version of the browser on everybody's computer. So that certainly complicates it, but we can all agree that maybe the core goals we should all be striving for.
Yeah, and to add to that, it is a slightly different problem space in IT versus OT. I think in the IT space, we're generally protecting data, whereas in OT, we're preventing outages. So protection devices such as relays and trip units are a good example where these were historically designed around safety, reliability, availability, but now security has become just as important. Or a PLC controlling critical equipment where timing and accuracy would now be as important and as robust security features. These offer some examples of devices that can't just be de-energized and upgraded without thorough testing of the application they're running. We need to ensure the code and protection algorithms and timing of operations are not affected by any of these updates. And lastly, just the global deployment of these assets can be a challenge from an asset management point of view. Related to the efforts of this work stream would be developing a fleet management strategy or how we handle bulk upgrades of a device in operation today.
Okay, thanks, Matt. Thanks, Todd. So moving towards the specific goals that this team has been working towards, I know that all of you have spent time on classifying different types of data and how they connect together. So could I get some information on what type of security context is important and how it can be used to determine whether an attack has occurred?
That's a good question, Megan. And I think there are 4 components to this that are necessary to address this in totality. First is identifying the who. What user made the changes or sought access to this information. This could be an account used for configuration or software or logic or used in logic changes. Next is the what, like what device or system is being accessed and what services are being leveraged. And then we get to the when, timestamps or at least establishing some type of series of events so that we can understand the sequence of events. And then lastly, the where. Was there a particular host external to the network that was interacting with these systems? Maybe even a location on the data center campus where the device is located, or even a particular interface on the physical device that was used, such as a service port. This information and corresponding operational signal really help in that analysis to determine what happened and to assess the intent.
I can give some great insight into how IT determines if there's been some form of attack. And as a vendor, we ask ourselves, what can OT provide in that case? There's a lot of signal, even if from some of those typically isolated or restricted network environments. Some of the details that we take for granted in IT security, like identity, don't necessarily exist in the OT world when you're talking about something like a building management system. So there's going to be some things that aren't necessarily known at the same level when you're talking about a low level of building control. While the who isn't always known from those low level tech, though, the what, the when, the where, those are something that is usually available from the operating system, the components that are making up that building management system. So we can provide a lot of supplemental detail that gives additional insight. However, much of that is very central and unique to the particular installation. So context is crucial to understanding that, even if the observed detail is normal or extraordinary. So as a provider of the building management systems and technologies, we're exploring what we can do to add that insight that helps the analysts and the responders piece together that total story of an event. We're right down to the physical components that are used.
Awesome. Thanks for that. So another goal for the team is to build out a standard data schema. What would be the benefits of doing this?
Yeah, so imagine you could just like take a device and plug it into network and you automatically got everything you want to know about it with little or no configuration or setup. If most of the information was available in a standard package or schema, then you can imagine we're halfway there already. It allows upstream monitoring and alerting systems to be much simpler, much more standard. And not only does it make this useful for security context, but it's also very interesting for operations and maintenance as well. Like for operations, this simplifies and probably encourages the development of supervisory or cloud controllers. Like imagine the ability to easily filter all the sensor data and actuators available across a particular domain of interest, like say the cooling stack. There are great tools today that let us process troves of data with machine learning, provided that data alignment and cleaning is done ahead of time. A schema really helps provide that abstraction and common interface to facilitate that upfront processing on all that data that's in all these devices you want to use. So whether you decide to use machine learning or domain expertise, you can then translate sensor information to performance metrics like PUE or maybe carbon these days, and back to your actuators to optimize for those particular metrics of interest. And you can imagine for maintenance, it's very similar as well. Now, instead of optimizing for a performance metric, you might just be interested in anomaly detection, for instance. It might be easy to set up statistical process control for variables that we know we want to monitor, but it's less obvious to figure out what are some interaction effects that might be important as well. And they might be just as important to look at. So, again, with machine learning, you can do things like unsupervised learning and clustering of data to help us with this aspect, but you need some of that upfront processing as well. So all of this is about making your data look the same so that you spend less time getting your data pipelines in good shape. So what does a schema look like? I think the short answer is it depends, right? You may have some requirements for your endpoint devices. You may have different requirements for your aggregation devices. You may have even other requirements for other devices that are on your facilities network. And part of our effort is to help figure out how do we classify these devices across your network and come up with different sets of requirements for these devices. But as a simple example, we might say for endpoint devices, we want to know version number, serial number, type of device, a points list, maybe like the operating system image checksum, and maybe a software checksum. Having these things really makes it more straightforward to perform asset management and software version control already. And you can go ahead and add in more variables and metadata about the function of certain variables. And now you have a much more interesting logical object to work with, especially with a high-level software language. So as the industry evolves and new parameters, metrics, metadata are needed to provide certain security contexts or operational benefits, we imagine these schemas can grow and evolve as well.
Thanks, Ehern. And thanks everyone for contributing to this discussion. So before we wrap up today, though, can you all let us know what our next steps are and how people can contribute and get involved?
Well, I think we all need to start that dialogue about the challenges and possible solutions between data center owners and OT providers. If we stay focused on the end goal, good security across the board, in a way that fits well with how security logging and monitoring work today, then I think it'll go great steps. Standards are certainly going to help us with that now and into the future. And standards will help the adoption of all parties involved to those new technologies and interactions.
Yeah, totally agree with Matt. We've started working with a number of standards organizations that have expressed interest to help shape the direction of this work stream. And we'd love to just get more people involved because we really want this to be a collaborative effort across the industry.
Awesome. Thanks for that. And thanks again to all the panelists here for your contributions to the space and meeting here today to discuss the unique nature of the ICS world and how we can move the industry forward in security. So to those listening in, as mentioned previously, our work stream is building a white paper focused on building guidelines for monitoring and logging in the ICS environment. And the more contributors to the more robust this solution will become. So you can reach out to anybody here if you want to get involved. We can get you locked into a lot of the meetings that we have going on, or if you're interested in other areas in the space, there's plenty of other work streams that are also working here as well.